Good morning, Dabblers. Kill Moody here, community manager at Dabl Club, and thanks for joining us for day 3 of our latest Dabl Club DevCamp. Special treat, we've got Lexi in the shot. She never hangs out here in the room with me while I'm on camera, so that's a good opportunity to get some of that doggy goodness. So without further ado, let's go ahead and get the man of the hour up here. Mel, what's going on? I think you're all ready to rock and roll today, correct?
PM, that is correct. Hope you can listen me well. And here we are, ready to dive into more code, more solidity, and just start getting more into, exploring more options that we have, starting to think outside of the box on how we can start implementing what we have learned in the previous week, was mostly, intro stuff and a little bit of solidity, a couple of implementations. So we will dive deeper into solidity and other patterns, other standards that we can see in the real world. And we can start thinking also today more on real world solutions. So today we will be going with a real world asset, representation only. We're going to tokenize a real estate property. We will fractionalize it. So we will emit ERC20 tokens that will represent a portion or a share of the property. And after that, we will create a vault where people can deposit these property tokens and generate yield on top of it. So, it's not necessarily a DeFi app that's actually going to be working, but we will be implementing some mock functions that will help us understand what's going on in a sense. So that's what we will be going through today. There are a couple of pending things on our side for the challenges, so we're still working through that. Don't worry about it. After today, you should have what's needed to get started with the solutions that we have, and the cheat sheet will be coming between today and tomorrow, so you can start submitting the challenges. But up until today, the only one that is really important is that you start thinking about the idea of what you want to build, because from today, it's where I will be leading more of the workshops, leading what we are building on or what we're working on. But however, the implementations of what you actually need and what your solution is actually going to be needing will be probably different than mine or than others. So here's where a little of the creativity starts showing up, and you will really need to start, exploring different things that we see during the workshops. Of course, with the previous knowledge that you will gain here, you should be able to navigate through it. And if not, there's always the our Telegram support group. So whenever you have a question, we will be there to help you. So that's what we have in store for today. Kale, let's start with the coding.
Let's make it happen, man. Absolutely.
So let's see. So what have you done for real world so far? What do we reviewed last time ERC20s, and I'm pretty sure you're familiar with ERC 721s, which are NFTs. There are also like the 1155, which is another implementation of NFTs for different purposes. But from what you saw last week, today we're going to be using Open Zeppelin, which is a standard that will allow, it's an implementation that will allow us to just move faster. What have you seen so far out of these kind of, deployments using existing infrastructure? Or why would you say it's like good to have for new builders?
For me, it's really about the realization that anything with like documentation, authenticity, anything that needs to be verified in the real world, those are perfect asset classes to be utilized for these kinds of frameworks. One of my original protocols that I played with, like when I first found crypto and really was diving in like late 2020 or so, was this approach of real estate on chain. And we've still yet to see this as like a perfect implementation. There's a couple teams that have tried it. And so for me, I think like you're mentioning still, the biggest piece is figuring out the idea. You've got to figure out like what it is that you can leverage the blockchain for, that it actually provides a value for, right? You have to work over there first and then come into the technology. The technology doesn't inherently tell you what you should build. So you've really got to take time to like slow down and think about what you want to build, and then figure out how the blockchain can make it in a more like efficient manner.
Yes, exactly. So for for today's session, we will be going a lot more into that part of the idea, or how to start thinking about this problem solving. Initially, especially for this example that we're going to give, it's going to be done with a lot of suppositions and yield generation, which is something that we haven't really touched on. How do you generate yield? There are multiple ways. I mean, what I want to say is, we will propose a scenario where we will expect our solution to generate yield upon deposit of fractionalized tokens of our real estate. But this is like a construction that we are doing. And once you actually want to start, finding this real yield, finding these contracts where you can actually deposit money and get interest, get yield, and be able to distribute to your vaults. That's something that we will see on the next workshop, which is more diving into existing contracts that help us create these vaults. And today we will be focusing more on the deploying fast with smart contracts that have been tested using open sampling standards for the ERC20 token, the ERC721, which would be the NFT, and lastly our vault. So let's dive a little bit into a quick diagram that on what we will be working today. So let me share my screen first. Okay. And you see what we were doing last week. It's over here. And now we will create a new diagram down here. We will keep this on top in case we need reference for the framework that we're using. But for now, we will just work on smart contracts and the idea. So the idea is here, let's say we want to tokenize real world assets. So you probably heard some kind of figure that, for example, for real world real estate is XX $billion market, and some of the problems is only a small fraction of the population has access to real estate. So what if we could tokenize real estate and give yield out to each holder of the real estates share, the states of the real estate shares. So it's saying that we have a real estate that we want to tokenize. And in order to tokenize, we will need a real estate ERC20 token, or rather a real estate share, which would be an ERC20 token. We want to tokenize the real estate, we can tokenize it as an ERC721 token. And you see, we'll start thinking of entities that we have in our world, which is, for example, the real estate. We can containerize it into a token that's representing it. So that would be the ERC721s, the non-fungible tokens. It means that each copy of this or each token ID. Oh my God, here we go. Let's see. So it says, for example, token number 1 has and properties. Let me just put T1 properties and just one copy. So this could be something in, let's say, GNYC, and this one could be, this is number 2. This can be Mexico City. Just put the initials.
And Mel, if we can maybe get some early thoughts, we don't have to dive super into the details here, but Johan's already interested in like why the ERC721 approach, opposed to like say an ERC 1155, without getting too deep into those weeds right now.
Yeah, it's mostly a preference. So 1155, the idea is that you just generate one copy, and each token ID can be the same as the previous one. So ERC 721 is more like each item of the collection can have its individual properties, but it's still part of a collection. And the ERC 1155, it's the same copy replicated, just with a different token ID. So let's see, ERC 1155. But with no, it's in Spanish. So it has more of a, I wouldn't say it's between ERC 20s and ERC 721s. Just 721s have a much more specific definition for each copy, and the 1155 is more for like a lot of copies, like drops. When you want to do a drop with the same copy for multiple people, or multiple copies, that's where I've seen the 1155. I might be wrong here. Like there's some like minor differences.
Sounds right to me. Yeah, it'd be like 1155s are like POAPs, right? Where everybody gets the exact same like carbon copy of the asset. It's just numerically different for the ID. Whereas the 721, the collection could be Mel's homes, but Unit 1, Unit 2, Unit 3 can all have their own unique properties, even though they're all part of the same collection of Mel's homes.
Exactly. So that's why we are doing 721s, because we need each token to have like its very specific properties. However, we want them to, we create like, and we will create some custom functionality. Let's say if we want to be able to link them to a share, or then we can ensure that all of them have access to the function, let's say calculate shares. And I'm just saying something in the meantime. But that's mostly what it is used for. Let's see. There we go. Then the ERC20 token, that's just for the stand tokenization, the shares, and then the vault. And this is where we will see a new one that we haven't reviewed before, 4262 token. And here's where we are going to start handling other people's assets in order to start generating yield. So the idea is that we have this real estate NFT that we will be able to, like each copy of, here we will need like ideally, we will need like a factory, ERC20 factory. So anytime this somebody comes and wants to tokenize their NFT, let's say you have a friend that wants to start earning yield on their tokens, and you are the company in this case. I'm just gonna put something here. And RWA company, startup in this way. So whenever a customer comes in and says, "Hey, I want to tokenize my real estate," so we're gonna come and we're going to mint real estate. Let's say NFT. So we're gonna call this function that we're going to create here, and we will generate a new token. Let's say token number, token N. So whenever we execute this function, we're going to get this this token. However, since we want to fractionalize it, we will need to then deposit this token into, let's say, technically it will go into its own, like this, but it goes through this factory. Forward. There we go. So what happens here is whenever we create a new token, this token is going to get is also going to trigger this real estate share factory, and the share factory, what it's really going to do is going to emit the ERC20 token that we need, but it's going to be linked, of course, to this token, to this new NFT, the real estate token, because we need to ensure that if we're going to emit shares on behalf of that NFT that's representing a real estate property, we need to have it deposited and logged into this ERC20 token. So we will deposit this NFT, and by that what we mean is that we're going to actually assign the property of this real estate NFT, this new one, to this ERC20 token, and we're going to mint an amount of shares. Let's say 1,000 shares. That's going to be the total supply. And from these 1,000 shares that we create, then people can buy, an amount's going to, we can define this. X amount goes to owner, and Y amount available for purchase. There we go. And after that, it means that would give us, let me move downwards this a little bit. That would give us a set amount of tokens. And that it's up to 1,000 shares. So then let's say that we want to also tell people, hey, you can also deposit this supply to the real estate vault, and any yield that gets generated monthly earnings. Let's say you rent it out. So this is the total supply that can get deposited here, right? And each month, we're gonna have monthly earnings. Let's say that you rent it out, and this can get redistributed back to, how I would put this. We want to send it back to our users, of course.
And Mel, just to clarify one thing here too, I'm just doing a little search on our cheat sheet, and it's actually the 4626 is, I think, the standard you're referring to here, right?
Oh yeah, sorry, yeah.
4626.
Thank you.
And then also just one thing here too that Manav's asking, is this also how they would coin images or videos on chain as coins? If they wanted to like have a digital asset that they wanted to like tokenize and have fractionalized ownership, the real estate's almost interchangeable with any asset, right?
Yes, correct. Yeah, the key part here, of course, is what officially says that it is yours. But yeah, that's the idea. So here, ideally, there should be like a strategy, aka strategy. And most of the times it is related to smart contracts or other DeFi protocols where you can deposit the token supply to that to this how do you call it, to this vault, and then they get deposited into that protocol, and any yield that gets distributed, it goes back to the vault, or you can define it inside your strategy, but it usually goes back to either a vault or a treasury contract that can handle this kind of management. For today's purposes, we will be depositing and keeping track of this value inside the same vault token. Well, sorry, yeah, it's a token as well, but this vault contract. And whenever the users want to redeem their shares, that's when they will get their token, the earnings plus whatever they earned extra from the vault. So the vault will be, so okay. So we have the real estate NFT, and for this one, we're just going to name it RE-NFT. Maybe you should have something like property NFT. And it's going to be property share. And this is probably it's going to be property V token. Let's call it token. Keep it simple. So this one will be just an NFT, simple NFT ERC721. Sorry, just this one. The property token will be an ERC20 token like this, and this one will be designed B token. So this B token is the one that will be generating yield. So whenever these monthly earnings get generated, these B tokens will be deposited here. So the idea is that these B tokens, of course, have some value, and you can actually swap them before redeeming. And that's something that because we cannot remove the current total supply, but that's a little bit of the strategies that we need to think about. So I'm gonna pause here and go once again step by step to what we're going to build. First, we will create a real estate NFT, which is just a tokenization of any asset. Can be real estate, can be coins, can be Pokemon cards, again, anything that you want to represent as an NFT. We're going to build like a very simple simulating a real world, a real estate property where we can store some information like, location, price, and how much other stuff. Then after that, we will go and build first a simple ERC20 token so we can start fractionalizing these NFTs. And once we deposit them into the real estate token share contract, and once we have those, we will enable this kind of so that will give us the NFT and the shares for each NFT or for each real estate. And after that, those shares, we will create a vault contract that will accept them as a deposit. And those share tokens will be deposited then into a strategy or somewhere else. They will be sent, like we will simulate that we're sending out this money or locking in, like depends on your strategy. Ideally, they will be used for other DeFi purposes. And any money generated will be deposited into this same smart contract. And the earnings will be available for the holders of the shares in proportion to their current shares. So if there are 1,000 shares, 1,000 tokens that were created, then we will create this distribution. So if the owner has 50%, then 500 will go to the owner, and the other 500 will go to the people who have purchased the token. So let's go to the coding, and we will repeat a couple of processes or tasks that we have done previously. The first one will be creating we will create and which one was this? This one, Onchain Fundamentals, there we go. So we will go and create session 3 from scratch, but we will create from our scaffold ETH starter. So repeating the process once again, what we need is Node. We're suggesting to use Node Version Manager. And if you need any help, I don't know, Kale, you can help us providing the URL for the.
Yep,
I don't have it on hand. Just so you can follow also some of the requirements and some some steps that you might have missed from the previous versions. You can check them out there. So what we're going to do is create with scaffold ETH, and all of this is part of on the cheat sheet. We will create this project. So just enter the command. Let's put how do I put? And that can work with 2. Okay. Camp 2 session 1. We're going to use hard hat again, and remember, when we start a new scaffolded project, we will get these two kind of frameworks. We will get Hardhat in our case, is the one that we are using, and you also get Next.js. So right now we will be focusing more on the Hardhat, so we can create the contracts, and we will be using a little bit of the Next.js just so we can debug our contracts on this very cool framework that Scaffolded has built, where we can just focus on creating the contracts and then it gets deployed into a front end. So this is once we finish, once again, we get, remember when we are using Scaffolded 2, we need at least 2, if not 3 windows. One, we have the local chain for our development purposes. We will be running a local blockchain, and that's already seeded with ETH, and it runs on our machine. And once we kill that blockchain, everything disappears. On the second terminal, we will be running our commands to deploy the smart contracts that we create. And whenever we want to test on the front end, we will need to start the front end application. So that's why I say usually 3. And so one for the blockchain, which is the first one that I'm going to be doing here. So let's move to our current folder. And here we will start our development blockchain. So that's why I said that we need at least 2, if not 3. So I'm going to split this horizontally. So now you can see that our local blockchain is running here. Everything is ready for us to start testing. And over here, I'm also going to open our code editor, which in my case is Cursor. So remember, this is our starting folder. We have packages, and here are the 2 folders where we will be spending most of our time. Hardhat for contracts and Next.js for our application. So by default, once again, just doing a refresher, Hardhat, or rather Scaffolded 2, comes with a starting contract that we can deploy. So this is a smart contract for the greetings. I'm just going to deploy it for anyone who might have missed the previous sessions. We run yarn deploy, and we're going to get our contract deployed to this blockchain. And if we run yarn start, then we get our front end running on port 3000, which is our Next.js application. And that's how we get our local local environment, our local web application, where we have even a burner address. We can get from the same blockchain that's running here. I actually just got, you see, send transaction. I got 1 ETH precisely. So we have access to that already. And on our contracts from what we just deployed, we have this, we can interact with this contract. That's the first one that comes with Scaffolded 2. So that's the beginning. So now we're going to go a little bit faster. Since we were reviewing last session more of Solidity, we reviewed variable types, we reviewed a little bit of inheritance, we reviewed write methods, read methods, and some modifiers that allow us to manage better or handle better our logic. Now we will be diving faster, and instead of doing an ERC20 from scratch like last time, or ERC721 or ER4626, is that the right one? Yeah, ERC4626. Perfect. Instead of us having to write all of that. And that's actually what I opened is just looking very quick for this. And we will be using Open Zeppelin's implementation. Those are usually very respected inside the ecosystem. So whenever you're working with smart contracts, it's actually very good to use Open Zeppelin smart contracts, because they have everything that you actually need, and you actually see some real world assets ideas here that we can also take if we want, but we don't really need right now. And all right. So what we were going to do for this is precisely accelerate our development by creating some smart contracts on our own. And the first one that we need, remember, is our property NFT, which is over here. I'm gonna keep this on the left for reference. So first we need our property NFT, which is an ERC-721. And there are a couple of ways that we can move to create this property token, property NFT, I'm gonna call it. And the simplest one would be, go with an AI. That's actually, I would suggest you to do that now and then, or rather to begin with, because it's going to, we're getting to that point where smart contracts are a very, especially Solidity ones have been built quite a lot, and as long as you review the very important specifics, where are you inheriting from and what kind of code you are actually pushing, but they're usually pretty good. So what I will ask here is please generate the code for an ERC-721 smart contract that allows the admin to mint new property NFTs, which represent real estate assets. So here I'm just asking it to generate like a base contract. I would expect, like I said, to start seeing a lot more of the inheritances that we've seen on the previous session. Because, for example, I'm just going through the Open Zeppelin, the wizard, and you can just search this very easily, Open Zeppelin wizard smart contract or something like that. Just add whatever is helpful for you, and you will find the contracts wizard. And this one's actually a very good resource because it allows you to very easily, this is an implementation of a basic ERC-20 contract, even with the permit function. So you can add your own, requirements with this wizard, and it is actually very good for like, especially for testing or learning. It's gonna be super helpful. And you can see here that tool it file transition to agent mode. It doesn't matter. Let's switch to the agent mode. And it's probably going to go and implement this ERC-721 contract, which is available. And this is how you would do it. For example, in our case, if you want to implement an ERC-721 NFT, we can just import the contract from Hardhat. It comes already from Hardhat, from Scaffolding 2. You already have it available in the node modules. So this package is available for you to use. And sorry about that. Once you import it, you just need to use once again this special this keyword that is for your contract. You're telling your contract, which has a name, my token, is part. It's like is a subset of this. Like it's extending or is inheriting from this implementation that is being imported. So that means that all the functionality that, as you can see here, Open Zeppelin has built into the ERC-721 is available for us. So we were doing this with the ERC-20 previously. So it's the same situation for the ERC-20. We had all of these required functions that the specification needs us to have available: the name, the symbol, the decimals, the total supply, balance of transfer. And us, only by importing like this, the ERC-20 token and saying that my contract is an ERC-20 token, that it is inheriting that functionality, this is a fully fledged working ERC-20 token. Same for the ERC-721s, ERC-1155. This stablecoin, it's also an ERC-20, so there's like no big deal. For the ERC-20, for the real world asset, it's also using an ERC-20, but you can just use whichever token or whichever contract is useful for you. And there's a lot of goodies here to go around. But let's return to what we were building. So precisely what our AI has given us is this implementation where it is inheriting from the ERC721.sol, and we actually have it available here. You can see all the code is available and you can review it. I would actually suggest you to review it just to see that it's actually going through the implementation specification. It's always a good practice to check that the code is right. And some implementations that the other one is the ownable, which is it allows us to set an owner and call this only owner modifier that as we saw last week, it only allows the owner to call this function. So the ERC721, the main functions that we're going to need, other than keeping, of course, similar as the ERC20, we need to keep track of who are the owners of which token. Like here, the token ID is actually important. We don't have this for ERC20 tokens, but we do have balances. So we will also keep balance of of which owner has which tokens or how much they have actually. And also, similar to the previous one, approvals and allowances. So rather than allowances, really approval here. And we have this new operator word, which is similar to the allowances that we had previously. But now instead of that, we just have, since we can only handle one token swap per operation, at least that's how the ERC721s are built, an owner has or doesn't have the power to move that specific token. Previously, for ERC20 tokens, since you can have X amount of tokens and it doesn't matter the order or which token ID each one has, you can just move balances like allowances. But now, since you're moving specific representations of an entity, it can only be one, and that's why we are using bool. And this is just another way to say this is similar as allowances previously, but for only one token. Then we have, this is just the ERC721. We have some of the functions that are required, the balance of, just to know for this, how many tokens the owner has or the caller has, who is the owner of whichever token ID, name, symbol. This token URI is specific for, to handle where our metadata is going to be stored. So if you, for real world assets, for example, for properties, you probably want a token URI where you can store pictures of the asset or the property. You can store more information, not only the ones that we will be using, but more information is recommended because blockchain shouldn't store a lot of information. And some others approved. Any other question that you have regarding the implementation of ERC721, trust Open Zeppelin, but if not, you can go and check the documentation. But that's the fastest way for us to move. And now we have here this token URI. Where do we have a lot of it? Okay. So the first, we have for our property NFT, we are keeping track of which is a token ID. So this is like an internal variable. That's why the agent designated it as private. And we will be using UN 256. That means like we can hold a lot of real world or real estate. The mapping, it's similar token URIs. This is just internal for us to keep track of the token URI. So very quick definition. So the cool part about NFTs is that they can store metadata, right? Metadata that allows them allows NFTs to represent anything. So what we want to do with this metadata is store the metadata in a format that is easily readable and always accessible. Ideally, it cannot be tampered with. I mean, depends on your definition, but like the idea is that if I have a registry where we're keeping information for a car, for example, or real estate, I wouldn't want that information to be able to be easily switched. Instead, if there's going to be an update on the price, there's going to be an update on who's going to be the owner or the new owner of the real estate property, that this doesn't happen just magically, right? That there are the proper steps to ensure that this information is going to be always available, always true, and easy to read to, like in a proper format. And that's where the NFT things came up. So that's what token URIs are. So we have this metadata that can be, it's usually a JSON. That's like the format that was decided. We have a name, and we could call this, let's open this, okay. Name could be cool apartment in Mexico City. And the description can be, whatever. And then the image has to point to a URL, right? Image URL. Come. And more information can have something like value, owner, timestamp. You can put any information here as you want. However, there's like a set that's usually like a standard. Well, OpenSea uses metadata. NFT metadata. So this is, of course, not specific, like super enforced, but ideally, I mean, a lot of companies have taken into this, or like projects really support this kind of definition, where you have image data, external URL, description, name, and then some other information such as attributes that shows, personality. You can put whatever you want inside attributes. It can be, for example, if it was going to be something related to real estate, maybe color, value, or like price, and the value could be, like this, a number, and current token shares can be there. So this is how you define this inside the metadata. And this metadata, like I said, it's a JSON usually. As JSON. And this is, at the end of the day, some data, right? This data is the one that usually gets stored into a URI. And URI is Unified Resource Identifier, which means it's like a URL where it is accessible. That would be like actually it's a URI. It's different than a URL, but it's mostly a URL. So it's just a website where this metadata is always going to be accessible. So this URI, it's what's actually stored into the contract as token URI a lot of the times. So that way, each copy can have its own metadata that it should be stored in its own URI. And this value, which is a IPFS, or it can be just Reddit image can be a Firebase URL where you're storing data, Supabase, whichever you're trying to use. As long as it's an accessible URI, you can use it.
So this is like where you have to consider if it's mutable or immutable based on like where the URI is referencing, right? If you're using something like permanent storage, like Arweave or IPFS, and it can't be changed. This is the idea of like NFT collections that have images that might change later if the owner shut down or ran out of money or something. It kind of goes to like Shruti's question here. I think it's a good chance to answer this here too. So she wants to know, you had to call the mint function to update metadata? Would that be a transaction recorded on the blockchain? How do you change this metadata after you commit to it?
Yes, for this, there's usually the token URI. You can set a new token URI, and that's how you would update the metadata. So it's more of a pointer instead of actually holding the data. You're actually telling the NFT where it should be pointing to, where the latest record is, like the latest true record, because depends on the storage strategy of each storage provider, so that it can be up for forever, right? But the one that holds the truth is this container of the token, and if the token is pointing to a specific token URI, that's where it's true. Like you can replicate this as many times as you want in whatever kind of definitions you need, but if it's not part of the NFT contract and it's not stored inside that NFT assigned ID, which within the token URI, that's not gonna work.
So I guess this is a better question there, that the token contract itself, the original contract, the 721 contract that you create, needs to have the function for the URI to be updated.
Yes, exactly. And this is something that we see here, for example. So that's why we need the token URIs and this set token URI. And actually, you see this conflict that we have right now on the smart contract. So we are storing the token URIs within a mapping. That way, we can keep track of token UID, exactly, points to a token URI. So if I want the information or rather the metadata for the token with ID number 5, that's how I would access. I would send 5 or call rather these token URIs like this, get the token ID, and that's how we will get it like this. So in our contract, we have this kind of duplication because we are assigning this variable. Yeah, the way we work through this. We also need to do it here. What's this exist? Okay. This is probably, I haven't seen, I've seen it before, but I don't think it comes from anywhere around here. So instead, let's see. Cell phone or name symbol. I mean, actually, we don't need this now that I think of it. We have already a token URI. Just going through the docs.
All the different tools in the machine.
Exactly. So yeah, okay. Okay. So we don't have this exist function. We could create it, but really we should be able to get it by token ID. So 256. Get owner of. Yeah, that's the issue. We try to do this. It's going to say non-existent token. Okay. It's very ugly. Okay, all right. Let's see if we can find it. Okay. So the only thing that we need to check here is that this token ID has actually been minted. So a simple way to do it would be just to check that the next token, this value, is actually, we check that the token ID that the user is asking to set the token URI, that it's less than the next token ID. So that means that it has been minted before. And if we do that way, we ensure that we can change the information that is stored for the token URI for that specific token, and we can send it this new string that we are receiving. And this would be the same for this one. Instead of the exist, we can just do it like this. It doesn't make any sense because we actually have this token URI here inside our, what's happening? Base constructor, ERC20, ownable. Okay, I was missing. So a couple of things that we need to take into account. Whenever we're inheriting from another contract, we need to make sure what are their required constructor arguments. So for ERC721, we need the name and the symbol. And we are sending it inside, like similar to what we were doing before with our constructor function. However, we also need to include the constructor arguments for each of the inherited contracts if they are required. And as you can see, ownable also needs this initial owner to be called. So that's why we were missing that one. And that's why we had this error, because it was saying that, hey, no arguments were passed to the base constructor. So we needed to include the ownable address, which it would be, in this case, just a message the sender. We can hard code this as well if we want. Then we have our mint function, which is receiving the, this is a basic implementation as well, ERC721 API. So there's no mint function, I believe, but we need to enable the transfer and the transfer from. And the mint function in our case will be the one that we will be using to do the safe mint functionality. So the mint is it's a transfer function at the end of the day. So we need to set who are we transferring to. In the context of an ERC721, we don't need a balance or amount of tokens to be minted because we're just minting one. We could, if we wanted to do like minting more, but it would be the purpose. We would need like an ERC 1155 for like this kind of operations. We sent also, which is the token URI, the URI where the metadata will be stored. And we ensure that only external and the owner can call it. And it will return the token ID. So here what it is doing is storing the, so private, it starts with 0, right? So we have two things that we can handle here. So depends on how you want it. You want to start on 0 or 1. That this is something like sometimes a lot of people, some people kind of get confused about. It usually doesn't really matter. Depends on how you want to do it. In our case, this is by default 0. So the first token that we will mint it is going to have token ID 0. Correction. It gets 0, and then it actually adds 1 at the beginning. So this is just about preference. Personally, it looks better as a 1, but I'm more for like an old school, so I'm just going to start it on 0. And it's going to mint with the token 0 first. Mints 0 first. And then we increment. So the next token will be 1. And we actually can do just could use like this. Oh yeah, I see what's the problem. So next token ID is 0. So okay, I mean, I don't love this, but because it's getting confusing now. Yeah, let's say that it starts with 0, like it was. It starts with 1. Okay, so that's why it says. Which I did. Okay, so it's actually going to start mint 0 1 first. And first we assign it's going to be 0. We increment it 1, so the first token that we mint is token with token ID 1, and then we will update our token URI, like we were calling this function, which is internal only, and we will assign for token 1 this URI that the user is sending, and that's pretty much it. In case that it needs to be updated, we can just set the token URI. So it's a very basic one. Other things that we could do, remember when we were creating, let's see, I'm gonna speed over because if not, we're going to take a lot of time. So this is a very basic ERC-721 contract. Now we will do the same, but for our property token. .sol. It's property shares. We said shares token .sol. And here we're going to do it with Open Zeppelin again. And it's going to be the shares for our smart contract. So we're going to allow them to be mintable, burnable. Permit is just a nice to have functionality, and ownable as well. Let's just copy this and paste it here. And as you can see, we are inheriting ERC20, ERC20 burnable, the permit, and the ownable. And here we're going to call it property shares token. And the constructor function in this case, it takes the initial owner as an argument for the constructor. The ERC20, we're going to hard code them to emit property shares token. It's going to be the name, and the symbol is going to be PST. The ownable, we pass it along the initial owner, which is part of our deployment arguments. And the ERC20 permit, I think we need to have it the same as the name. Yeah. Okay. And the mint function. So a couple of things that I want to do to begin with. We're going to mint to the initial owner. Yeah. And initial supply. And this should keep our so that's a cool part about the inheriting, like the mint function and the ERC20 function, we will always have access to the balance, the allowances. We don't have to take care of that. So whenever we want to get this initial supply and the total supply, we can just get it from the previous implementation. Where is it? Here we go. Total supply, and you can just call the total supply function. So this is for the mint. And we can also set, let's say, so if these are going to be if this is going to be the smart contract that's going to represent the fraction or fractionalized real estate property, we should define certain like starting points or rules. For example, one thing that I believe should be obvious here is the amount of shares. So let's say UN256 public constant can be max supply, which should be the name of the shares. And here, remember that we have this decimals, uncomfortable decimal thing. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is, maybe we should just define, was it either? So this is one way to say, hey, I only want 1,000, since it's an ERC20 token, remember that the decimals by default is 18. So if you want to switch different decimals, make sure to modify it. In our case, we will be keeping this standard from Solidity. And when we say 1,000 Ether, it means 1,000 times 8 times 10, sorry, to the power of 18. So we have all of those 18 decimals. So I'm just making it easier on our eyes. So this is the maximum amount of tokens that we will be allowing there to be. Okay. So that's just like a basic requires, just so we don't overmint. And lastly, I'm also going to enable this kind of sale function. So function by shares. So if we want to sell want to sell shares, we need to put a price per share. So this could be done in a couple of ways. So we could put like a very constant price, share price. However, I think it's ideal for this to be set on the constructor function, so we can initialize this. We can have this kind of price initialized whenever we need to reuse this token. And whenever somebody wants to buy a share, the only thing that we would need is this. Okay. That's fine. Share price. So that's simple. So in any case that anybody wants to buy part of this share, we would require them to send the amount of shares that they want to buy. We will multiply it by the share price, and we need to ensure that the message.value is equal than the calculation. Otherwise, it's an invalid amount. If it's over or under, that will not work. So this is like a basic buy function, and we can also create this. No, I like the previous one. That's like set price, set share price, and I think that's enough for now. So that way we can ensure that. Let's see. I wanted to see if we can do like a lock, but it's not necessary. Okay, so we have these two tokens, and first let's deploy them. So we can compile them first, make sure that everything on our code is correct. So we have it right, the code is working, and now just a couple of things that we need. Remember, when we want to deploy our contracts, we need to use this deploy script that's inside the hard hat folder, deploy folder, and it's called 00 deploy your contract. Here, just to make it fast, we will first deploy the ERC721, which is property NFT. This one doesn't have any. I'm gonna switch this address. Michelle owner. So it's you can use it as well for the initial supply and share price. Okay. So for our first contract, I'm actually going to use this address that I have here, just so we can start. And now run and deploy. So we deployed property NFT. Now it's going to kill the front end for a bit. And now I will now we're going to deploy. So I just need to move this. It's bugging me. Okay. Now we need to deploy the shares token. I'm going to keep the same owner, but we also need to set a couple of additional arguments. So we said first we need the initial supply. So the initial supply will be how much we're going to give to the owner that's going to be calling this function. And the share price is just going to be actually, share price is not exactly what I wanted. I want it to be calculated. I mean, I guess we can just calculate it here. So for this one, first is the initial supply. So let's say that the owner wants out of the 1,000, it wants 30%. But remember that we need to send the begin value. So here we pass ether as a string. So I'm setting 300 ether or 300 tokens, and it's going to be sending it to begin, so we don't have to handle all of the crazy, decimals. And the last will be the price share. But ideally for this one, we would need to deposit, or rather enter, the value of the property divided by the amount of shares. So I can just put this on here. Const shares, share price. So let's say, I don't know. Let's say it costs 300,000 times it also plays at 1,000. And here's the only thing that would need to be changed is this price. Let's just const max supply. So that way we can enter share price to string. Okay, perfect. Now okay. I think we deployed twice the property NFT, but shouldn't be a big problem. Start. Okay. So why is this your contract? Let me. Okay, so we have property NFT, the shares token, and it seems like the contract's still over there somewhere. Anyway, so this is the NFT. Let's say we want to mint. Let's mint myself. Oh, this is not the burner wallet that I put. No, I'm not gonna be able to do it. Okay, and let's comment. Oh, my bad. I want to use the burner wallet. It's gonna give me a different one. The time. I'm not gonna be able to mint it to myself because I put this owner with a different address than me. And if I restart, does this get a new one every time? Now we can just remove the. Yeah, remove this.
And just one from Shooter here too. That's the math you were just doing there. That's you setting the initial share price, correct?
Yes, in short, what I'm doing is, yeah, exactly. Just like making it easier for us to handle this share price instead of doing the math here because it has to be sent as a string. Not big deal. But I haven't deployed anything here. Let me see. Nothing should be available. So I think the jar and clean. Let me see if there's something that I can clean the artifact. Post install next. Now let's see, remove them. But okay, seems like it was still getting the previous artifacts. Is what's bothering me right now because I wanted to show before deploying. They're still getting loaded here. I think yeah, this is incorrect. I'm not sure why this is still kind of. Let's try to deploy them ourselves. Okay. Now these two get, okay, yeah, that worked. And if you want to mint something, can mint it to my own address here. And let's just put like whatever URL in the meantime. Of course, nothing's gonna show, but this is just to show that here I will have an NFT now. And if I enter my address, I should have one here. Okay. And the owner of one should be me. And token ID 0. Okay. I thought we had changed that. Let's see. By the property NFT. Oh, okay. Okay, I see. Mint 0 first. That's why it's using this token ID. Okay. Got it. So we have the ERC-721 and we want our property shares token. So here, ideally, we would need to a better way like to link the property NFT to the shares token. So you have like kind of this way of locking the NFT properly. And this would happen for this. We could do it here that whenever you want to, I mean, that will be handled more on the here on the factory ERC 20. That way you could have like a real estate NFT vault. Not a vault, more like a lock or escrow. And that way this token will be sent to this address. And that way you ensure that this token cannot be moved anywhere else. So this is something that we didn't build into our, because we haven't done the factory over here. But ideally this will be handled like this. So on one hand, yes, you mint or emit the ERC20 token. You create that token for your real estate. However, of course, that NFT should be logged somewhere, that like an escrow contract that ensures that you and your shareholders actually are like assured that that NFT is on a custody that is not accessible and not easily accessible, so nobody can just rock you. But there are mechanisms that you can release this NFT in case that somebody owns all of the shares or whatever kind of logic that you want to apply to it. And okay, so we have these two tokens, and now we will move towards the implementation of the 4626 token. So this one as well, what we want to do now is, let's move to here. So right now, what we want to do is simulate this kind of vault strategy, or rather than vault, it's a vault where the strategy will be on a way to distribute the earnings of the token every time. So let's say that it's a 300,000. How much does 300,000 home cost? So let's say it earns $3,000 per month, 1%. So what we need now is for us to be able to simulate this kind of depositing of the ERC20 token that we can have on our account, because we will be buying some of these ERC20 tokens, representing that we are buying a fraction of this apartment or this house or whatever. And once we get them, if we want to be able to earn part of the monthly rent, then we will need to deposit our shares into the vault token. And whenever there's a deposit for the monthly earnings, these monthly earnings will be distributed towards anyone that is part of this vault. So let's see. There are several things that can be tricky here. Let's make it simple, and let's close this and build this contract. So once again, we have a 4626. I think we have it here. Okay, but OpenZeppelin does have an extension for the ERC 4626, so we can just use it. And let's call this property shares vault.sol. And here we are going to first do the SPD license and our pragma solidity, and we will say that this one is going to be an ERC 4626. Isn't finding it import. Okay. And for this, I believe we can just call this. Okay, first we need to declare the asset that we will be receiving as part of, that we will be accepting as part of the deposits, okay? And I'm putting it as asset right now because, as address, sorry, because we will be using another another word for this. We'll see in a bit. But what we will be really storing here is the token that we will be using as part of our deposits, which would be this property shares token. Remember, since this is a smart contract, we are deploying this and it's getting an address. At the moment, I'm going to leave it as address, but then we will change it to an ERC20 implementation. And let's check it here. Really, what the ERC 4626 is requiring on the constructor is an IERC20 asset, and this is a new something new that we hadn't seen before. Here, whenever you create a contract, remember we did this on the previous session. Let me put it very quickly here. On our previous session, we had a factory contract that created ERC20 tokens, and every time it was requested to. And whenever we wanted to do this deployment inside our smart contract, we were using this keyword new. And whenever we were declaring our token, our smart contract implementation, let me see if I can close this. Here we go. So this is our previous smart contract that we worked on last week. And here, what we were doing is deploying a new ERC20 token that we had already created on this contract. So for us to instantiate a new smart contract and deploy it on the previous, like what we did last week, we use this basic ERC20 token, kind of initialization. And with the new keyword, we deployed a new token. However, this kind of entering the basic token like this as a keyword, where we're declaring the type of variable that we are actually declaring here, we're just indicating that this variable called new token is going to be a basic ERC20 token. We can do this with any other smart contract. And this is something, I don't remember what was the exact name, but it's like you're wrapping, you're like forcing the type to the variable that you're declaring to it. You're forcing the type and giving it this kind of superpowers. So the new token, in this case, when we do this, you kind of wrap it under the definition of the basic ERC20 token. And you see how I even get this kind of auto completions, because since our new token is a basic ERC20 token, it has the functions that the other has, that the implementation has. So that's something very cool that we will be using eventually whenever we want to interact with a Uniswap token contract, or rather pool contract, with a Morpho lending contract. With these vaults, you can instantiate, or any ERC20 token, you can instantiate them by using this kind of cool type forcing. I remember the term, sorry. But this allows us to take pretty much any contract that we have the contract for it. I mean, any type of contract or any type of, if we already have their implementation, we can use it to our advantage. And that's what we will be doing here. Here, that's what Open Zeppelin is doing. They are instructing, in order to use this 4626 smart contract for the vault, you need to initialize it with an ERC20 type of variable. And this means that this is an implementation of, or an interface. That's why you see the I here. It means that it's the interface for the ERC20 token implementation. That's a little bit, obnoxious. It's not like the best. However, it's just how we will use it. The interfaces are like the most basic definitions, and really doesn't have any functionality. You're kind of just declaring it, and they are actually, I think, whenever they're called interface, it just tells you that this anything that's wrapping the ERC20 has this functionality. And what we're going to do here is we're going to follow the same as they are doing on Open Zeppelin, and we're importing the interface for the ERC20. And for our asset, instead of calling it address, we're going to call it as well an interface ERC20 public asset. I think it's actually has to be ERC20. Yeah, I think so. Let me check something. Metadata. It should be working. Okay. The asset. What else I'm missing? This one just requires one, right? The asset. This we should remove. Let's see. Give me a second. 4626 constructor. Yeah, this is fine. And we just need to why it doesn't like it like this? No arguments passed to this constructor. What? I didn't see that. I think so. So this constructor is only asking us for the asset. But this one's also on ERC20. Could be that. Could be that. ERC20. Yeah. Okay. Sorry about that. So we needed to initialize first the ERC4626, the asset. And actually, we don't need that in that case for our, because it's already going to be saved inside the, this as well. It's going to be saved inside the ERC4626 implementation. We will always have access to this asset on the private, but we can call this probably in another function. There you go, the asset, and it returns the address of the proper asset. And that's a token that we will be accepting. So there are a couple of things that we need to take into account, which is precisely as Cursor is suggesting, the deposit function and the withdraw function. So here, let's see, withdraw, why does it show like this? So here inside the 4626, we should have the definitions for the withdraw and the deposit. So here we have the deposit function, and we can see that there's a max deposit that allows you to up to define the maximum deposit. It's not really used. That's just in case that you wanted to put a cap up until how much the users can deposit on your vault, but by default it's like uncapped. until all the value available for the UNT 256. Then assets, yeah, if it's larger than the max assets, same as, yeah, that's what it's looking for. And then it goes preview deposit assets. So it gets you like the proper share. That's what the preview deposit and preview redeem. You can call them to get the estimate of the share or the amount of tokens that you actually have. And in case that for the deposit, it converts your depositing assets into shares once again. So this might be also a little, we're kind of fractionalizing twice. First for the ERC 721 to 1,000 shares, but then these 1,000 shares need to be fractionalized once again because that's how they're going to be generating the yield calculation, or rather the shares distribution. Rather than the yield calculation, they're going to use it on the smart contract to calculate out of the proper earnings how to distribute them according to the fraction of the amount that's available on the vault. And that's what the preview deposit does. It gives you the amount of assets, and then it calls a proper deposit function where it deposits on behalf of the sender to the receiver. And in this case, the receiver can be this very same function, or it can be also like in case that you want to have them stored somewhere else, can be, I think it's probably, could be that you can send it directly to another treasury or something like that. Here, deposit address receiver. It's rather, sorry. The caller is whomever's going to call the function, but the receiver is the person or the entity, the account, that's actually going to receive the vault tokens. So that's what happens whenever you switch from your share token to a vault token. Like we said, you had a property token, and then you property share. Let's go switch the name. And this one then would be V shares. So these one are kind of like, they're IOUs in a sense, because you can always, in theory, redeem your shares if I exchange them to someone else, or I just transfer it to another address. You should be able to get a one-to-one redemption on the token that you have here. So right now, what we're going to do is going on our smart contract, we are receiving these deposits, and we are from a caller. However, we can issue these V shares to whomever the user indicates. And here, the assets is the amount of share tokens that they are actually sending, and the shares would be these IOUs, or like redeemable tokens that we will be minting on their behalf. So inside the deposit function, that's what's happening. You can see that we are sending, we say transferring from the asset. The asset is on top here, right? Yeah. The asset. And then you are, this is just like a specific implementation of the of ERC20. It's a bit safer because it handles other kind of best practices, and that's why they are using it here. In short, what it's happening is that it's just sending your tokens to the minting first. Okay, let's withdraw. Sorry, it's over here. So you transfer from the assets. Whenever you're depositing, you are sending it to, you're indicating here which is the contract address that you want to call. Then the caller will be who is spending in this case, is safe transfer from. Here we go. The token that you want to send. Who is sending the token? Who is it being sent to, and the value. So it's basically just transferring the deposit on behalf of the user that's calling this function to the vault in this case, because that's why the address is this. It's also like a interesting way to call the address. You can just enter address this, and it's going to use the address of that specific smart contract. Also, other that you can see is address 0. This is whenever you want to like burn or mint from 0. So that's what the safe transfer from is. And then once we execute this transfer on behalf of the user that wants to deposit the money, once this happens, we actually mint to the address that they decide the shares that they actually bought. Same for withdraw, just on the other side of the table. If it's on the corner, then we need to spend allowance because we are withdrawing on behalf of somebody else. This is related to the transfer from and what we saw last week with the ERC20 token. Whenever we are handling balances on behalf of somebody else, we need to spend allowances. So that's what this is happening if the caller is not the owner of that token, of those tokens. So the shares are burned. If everything goes well, then we transfer back now from the asset to the receiver, and we determine the amount of assets that we're going to actually be sending from what the user called, and we just emit the withdraw function. So we're already removing the shares, and we are sending back the money. So that's what the deposit and withdraw function do. Sorry, deposit and withdraw, yeah. And what's the withdraw? We have 5. Expected 3. Which one am I missing here? Oh. Just magical withdraw. Okay. Yeah, okay, perfect. So it's the assets, the receiver, and the owner of a token. But why we would need to do a withdraw? No, this is not required. Actually, this one's not required either. So now,
Mel, can we look at the diagram real quick? I have a thought I want to ask before we get too far into it. So you mint 1,000 shares on the property shares portion, the ERC20, right? Okay. And then we go into the V token, the 4626. Is that an opt-in action, right? Would a user that's holding one of those ERC20 tokens be choosing to actively deposit it and receive this V token? And if they don't do that, then they're not included in that V token vault. These are separate things, right? And this would require the user to choose to make that deposit.
yes, exactly. This is like, imagine this is like accessing a Uniswap pool. Like, I'm not sure like what's the exact implementation. Wouldn't surprise me if it was a vault. Just need to check on that more specifically. But at the end of the day, this is just a completely opt-in that you can, as a user, just enter and deposit tokens, and you get back these
your receipt, your deposit receipts, almost like an LP, like you said, like a Uniswap pool or something like that. Yeah. Okay, cool.
Something
and so
very common, staking, for example.
Exactly. Yeah. Similar to staking in terms of like the action path here. Yeah. The user has the original thing, puts it in this other box, and then they get a receipt out of that box proving that they have something in that box.
Exactly.
Got it.
So let's go and deploy this contract. Okay, and for this one, there's also a couple of things that we could do, but yeah, we're getting running late. And for this, I think I only set the owner. No, not even that. The asset. Okay. For this initialization, we would need to send this token that we have deployed previously. It's gonna be interesting. Not sure how I can get this to work. So maybe I'll just fail this deployment, or just do this first two and then the last one. Yeah, that should be okay. Let's kill this and this. Restart the chain. Now if I deploy, I should have 2 successful deployments and one that will not be good. So property NFT and property shares token, perfect. And now I need this address. I'm just gonna call this first and second. I think that should be enough. Oh, no, it's wrong. It's over here. Let's see if this works. Okay. Property shares vault. I think that should be good. And now we can start our app server. And what I will show right now, and we'll not have enough time to show like some hooks that the 4626 has available, in case that we wanted to get these calculations, and I'll explain it and see how far we can go. But for this, it's over here. Should be able to restart this, and okay, now we see our shares vault, and we have some shares token here as well, 300 each. That's a little more expensive than I expected, but it's a lot of money. Okay, yeah, because it's 300,000.
Yeah, simplify the decimals. Yeah, it looks good. Nice.
So
Good
I'm
job.
gonna need to get a lot of
testing. this is why they always need 20 test teeth, huh?
Yeah.
Your decimals matter.
Yeah, it's gonna be a pain. But let's see. Yeah, let's switch that very quick. Share price. Let's just put 1. Oh, but it's not this one. Something like this. I don't remember is my, yeah, this should be okay. Yeah, actually, let me kill this. We start here. And hold on. Because this one's not gonna run correctly. Okay. So okay, those 2 are correct. Hang on a second. Oh, I forgot to copy this. Property shares token. I think it's the same. Nice. It's again deploying. Okay. I didn't think about this. I have to move this very quickly because I think. Oh yeah, no, it's gonna be okay. Apparently. So now we can have. I mean, we had the property NFT working before, but now it's still. Oh, this doesn't seem like it got the memo, or maybe I put it in the wrong. The Pluto. Yeah, I think it should be. Yeah, I didn't change this. My bad. Sorry about this, guys. A little repetitive. Okay. Let's see now. Mm-hmm. Now, yeah, that's what I was fearing. Okay, I'm gonna have to do it with my wallet because let's do this. Because I don't remember my password. I haven't switched it. Yeah. Sorry about that, guys. Just gonna use this. Just because the burner wallet it refreshes every time, so yeah, not ideal. Just gonna start, and I'm just gonna switch the here the owner for this. Oh, it should be okay. This and for this. Deploy. And here's our. Seems like everything worked this time. Oh, sorry. Still here. Debug contracts. It's not running. And now what we will do is we're going to mint some tokens on the ERC20, and we're going to deposit them into the shares vault, and we will show that we have X amount of the shares token, or rather the vault token. And yeah, just explain very quickly how does the yield or the strategy work on in the vault. So first on our shares token, now we should be able to buy. Perfect. And I can just buy shares. Let me try buy 2. So we have to send to. Let's see. Yeah, okay. So now I should have. Yeah, I only bought 2. Well, you can see that I bought some, right?
You get the fractions of a fraction.
Yeah, it's always 9 valid amount. You want to buy one. No, that my bad. What was wrong was here. So I did pay 2 ETH, but
Oh, you pay 2 ETH
but
for
yeah,
the 18 decimal
for
two.
the show. Yeah, I mean this is okay, but
It's just a matter of decimals. Yeah, just getting your numbers right. But in terms of the functionality, this is you grabbing shares.
It's an invalid amount. How is that an invalid amount? It should fail, yeah. But I don't know what I did wrong here, but 300. Invalid amount by shares. It's in our code very quickly. It has to be the exact same. Okay. The message value has to be the exact same as amount times the share price. The share price is 1 as this decimal thing always gives me crazy. So this is insane. See what I did wrong. The code buy shares, we're receiving an amount, but the message value has to be the uint amount times the share price. So if the share price is 1, the value has to be the same as the amount. The value, the share price is 1 ether times the amount. 1 ether times the amount. So I will need to pay. Nah, this is insane. I mean, now it's working, but it's asking me 1,000 ETH. I don't have enough. Yeah, the problem is that it's minting like the amount here. We're not sending the proper. The share price is 1 ETH, but the amount is just because the amount. Maybe we'll start with 0.1. This is what I don't like. So the share price, that one is 1 ETH. Because, yeah, it parses 1 ETH. So it's. So the amount, the message value, if it's only. Yeah, because you cannot multiply. It's a lot of shares. Times 18. Okay, I'm gonna stop there. It's a matter of like going through the math and the share price. Yeah, it's
No, that's fair. That's fair. Yeah, now you're just trying to get all the details lined up, but the tools are lined up. The strategy makes sense. You've created what you drew out on that diagram today.
yeah. The tricky part right now is that we are sending. I mean, in case I wanted to just get one share, but the shares are not being counted as a whole, but rather like a decimal, a very small decimal, and that's why we're getting these crazy amounts that it's actually accepting, which yeah, it's not worth it. Like to yeah, this amount's insane.
Well, the
Because
invalid
if I
amount
only
too is set up for over and under, right? If it was underpriced or overpriced. So like you absolutely have to do that conversion perfectly.
yeah, I mean, I can do this and I get like this very small amount, and I guess I can try to deposit this. Wait, but I probably already have some. Let's see,
Yeah, you should
balance
have
of.
3 or 4 of them now.
No, not only that, but I also minted myself the initial supply. Okay, yeah, it's not bad. We can try it with this. Perfect. So here now we go to the vault. Forget about this. But we can just do a deposit. And here we will be depositing, we need to deposit the property token, which is the one that's over here, the shares token. So let's say I want to deposit 100 and I want to receive the tokens myself. ERC 20 insufficient allowance. Okay, I need to approve. Say I want only 100. No, but that was my wrong. It shouldn't be to me. Should have been. I think it's no. This is a vault. So I need to approve first because the vault is going to be handling money on my behalf. So whenever I call a deposit, I actually need to approve first this transaction. And now I should be able to send.
When you approve that for the vault, is that across all individual users that were to interact with the vault, right? That's not like your specific allocation. It's the vault's allocation, the vault's approval in total.
Yes, and I actually think I need to do it on this one. No, I need to write approve here and to allow the vault to transfer on my behalf.
Yeah, so this
First,
is the you as a specific user individually approving, and then the vault itself has to also have approval to handle those tokens.
yeah, the vault would need it to handle the shares tokens.
Right.
Yeah, that's like to each their own. Yeah, now that we approved, I can send these 100 tokens, and
Look at that.
now my current, this will show the shares token, which is 100. Perfect. And if I wanted to convert, what was it? Max withdraw, where I can withdraw is this. It's the same value because we're just keeping like a 1-to-1 ratio. But here's when it starts changing. Whenever we inject back some of the assets that we are generating from the strategy, like in this case, we get some assets and we deposit them, we have to increment the value. It's better, it works better with stablecoins, of course, because here we need to add the component of volatility. But that's part of what you can return, like this speculation that happens on the yield generation of your tokens starts to create these kind of gaps that we've seen all the time with staking tokens, for example. And here's where like the creativity starts growing. Like, what are you going to do with this money that or these assets that the users are depositing? Can you create multiple strategies? Can you create multiple vaults that actually represent better the value? What kind of like I mean, you can connect it to any strategy you want. You can do lending markets. You can do, arbitrage. You can do liquidity pools. It's really fun when you start thinking about it, and it all starts from this very basic principle of depositing and withdrawing tokens. But yeah, that's it for the day.
That's a lot, Mel. Like you mentioned, you warned us last week that we're going to get into the complicated parts of it. This is definitely starting to get tricky. Even just having to make sure your math is right. Setting up the contracts, using these templates, following your diagram as you initially. That's part of it. You got to think through that mentally, and then you got to make sure all the actual numbers line up and all your references, your variables. It's definitely a lot of moving pieces, but good job. This all makes sense.
Yes, and the most important thanks, and definitely, I mean, it's also been a learning experience for sure. And the part that's most interesting is how you can start connecting more, more options. And I'm just gonna brush on it very quickly. You also have a couple of hooks that you can access from the 4626 implementation that allow you to execute logic before and after. Where was it? Before and after the user deposits or withdraws tokens into the vault. So here's, like, for example, imagine if you want to accept any token, or like the major tokens, maybe ETH, maybe wrap Bitcoin, maybe, I don't know, like a good stable coin, USDC, or you want to accept local stable coins, and you want the users to be able to just deposit which, like, let's say 5 coins that you accept. You can create like a hook use here that allows you to process the deposits, and eventually, like, if they are entering ETH and you only handle USDC on the pool, you can convert them on behalf of them on the pool. Well, I can find them, but there used to be some hooks that you could access. I guess you can also implement them between your deposit and withdraw functions. This is the interface. 626. But yeah, that's the idea. Like, you need to start thinking on what else can you provide to the users other than just like depositing and giving them IOUs, but rather with those assets, can you give them access to Uniswap pools where they deposit, USDC, and the risk. I mean, they could definitely directly deposit into the USDC, but maybe it's an ERC20 token that you want to give it some utility. That's something that you can think of, and giving it also not, double like utility, because in case that they deposit and stake, you can receive extra tokens, and that makes it more valuable. Like, just start thinking of ideas by leveraging these 2 basic principles and allowing you to access between that withdrawal and that deposit, how to handle fees, how to handle logic that can make your app more usable, maybe some cross-chain eventually, things like that. So I'm gonna stop there, Kale, for today.
It's a lot.
Yeah, next session we'll be diving into Uniswap, because we will be enabling this kind of functionality that I just mentioned, that accessing first swaps from before accepting USDC for ETH or vice versa, and the second one will be accessing to these strategies like a Uniswap liquidity pool. We will be depositing these tokens from our vault into a Uniswap liquidity pool, and show how does that look on the contract side, and on the front end, just very quickly, how we can start thinking on interfaces, or how we would like it to look for the users. So,
makes sense to me, Mel. All right, folks, if you have to watch this back a couple, 3 or 4 or 5 or 6 times to kind of let all these concepts soak in, you can find the recording immediately at our X page, Dabl Club on X. We also have it available on our YouTube page. Those links are here up on screen for you. And then the next couple sessions, we got this today was session 3, so we still got 4, 5, and 6 incoming. You can find those on our Lemonade page. Lemonade is similar to Luma in some ways, but a little bit more Web3 native. So lemonade.social/s/Dabl, and you'll find the calendar for all of our incoming sessions. But like we mentioned, they're all recorded, so it's okay if you're not able to be here live with us. The best way to get resources, in my opinion, is you got to ask your friends, you got to ask your fellow dabblers, got to ask Mel. And so the easiest way is to dabl.chat, and that'll dump you right into our Dabl Club Telegram group chat, where you guys will find that there's a dedicated topic for our dev camp, and we can kind of get those specific questions or those specific hangups or screenshot sharing, whatever the case might be, to get you the support you need. So that way we can get you over the hump and turn your diagrams into functioning contract loops, because we're getting to that complex part. So don't get too far left behind. Don't be shy to share where you're stuck or where you're having success. And let's just keep dabbling and learning more. And I'm looking forward to the next session with you, Mel.
Yes, likewise, Kale. And yeah, I know that we're moving faster, but it's all gonna come together, and it's all about trying it yourself and really, breaking your heads a little bit. So if you start feeling like, whoa, things are getting hard, it's perfectly normal. Just communicate it and trust us. It is hard at the beginning, but the more you do it, the easier and funner it gets. And when you start seeing everything happening as you want, we'll be doing later some test driven development, so you can also see how properly to try out smart contracts. But yeah, it's gonna happen, and just make sure that you communicate these struggles or any questions. You'll see that nobody likes to everybody likes to know things, so it can be embarrassing to ask questions. But trust me, that's how you learn. Like, if you think that's gonna be a dumb question, I've never heard one that's dumb. So just ask, trust us, really ask, and really use the community, because that's what it is for.
We're here to help you learn. All right, friends, go get some lunch, watch the recording a little bit later. We'll see you in the Telegram chat, and we'll see you on Thursday for our next session of the week. Have a wonderful day.
See you guys.